Hey, welcome back to Rithmetic with Ron. Today we're going to answer the question, how do we do unit conversions? Whether you're converting from inches to feet, yards to miles, different speeds, even between the English and metric system, we're going to show you how to do that today. Enjoy the video. Let's go ahead and start today's discussion by answering the question, how many meters is 300 feet? So we're going to go equals question mark meters. Okay, we just had the Super Bowl. A football field is 300 feet long from goal line to goal line. How many meters is that? We want to do a unit conversion. We're going to change from these units measuring feet to these units measuring meters. When we do problems like this, what I'm going to show you today is filling in these boxes. Okay, so we're going to start by drawing this diagram, and then we're going to fill it out with the information that we need and solve the problem. When you do a unit conversion, this first box here is going to be the information that you have. This is the thing that you know, or the thing that you are given. In this case, we are given 300 feet. That's what we're told. We want to convert it to meters. So the next step is to fill out this box right here, this set of boxes, and this is called a conversion factor. I'm actually going to write that on here. Okay, a conversion factor simply means a fraction that equates two different units together equally. All right, and I'll explain that after we fill this out. What are the two units that we're trying to convert between? Feet and meters. So those are the two units that are going to go in these boxes. And what we're going to do is remember that if we want to get to meters and we're starting with feet, then we put what we know in the first box, and then the same units are going to go down here. Okay, so in this conversion factor, whatever we started with, we're going to put the same units down in the bottom, and this is going to have a measurement of 1. Okay, and then up here are the units that we want. So I'm going to put M for meters. These are the units that I want, and these units here are what I started with. Now what I need is to fill out this number. Okay, what number goes here? Well, the number is going to be whatever is equivalent to 1 foot. This is a conversion factor. That means that the information on the top and the information on the bottom are the same, but in different units, okay? So what we can do is we can look up online or in a textbook, and we will see that the conversion between feet and meters is this right here, okay? What this means is that imagine that I were to draw a line like this. If I measure this line in feet and I get 1 foot, then I could take a meter stick and I could measure this same line, and it would be 3048 meters. This line is the same distance. Doesn't matter what kind of a measuring stick you use. The distance between these 2 points is the same, whether I use a ruler that measures in feet or whether I use a meter stick, okay? But because they're different units, they have different digits. But this conversion is a measure of equality. Let's say it like that, okay? You could say that 0.3048 meters is equal to 1 foot. They are both the same distance, okay? Now, what I'm going to do is I'm going to remember that any number can be divided by 1. And the reason for doing this is because now I have a fraction times a fraction. And if you recall that solving fractions that are multiplied is as simple as multiplying straight across the top and straight across the bottom. Okay, so I'm going to erase this section right here so we can finish the problem. Okay, we have filled out all the information, and now what we're going to do is multiply the numbers straight across the top, and we're going to multiply the numbers straight across the bottom. There's one more important feature to talk about, and that is, why did we put the same units diagonal from each other? The reason is because when you multiply fractions, if you have units that are diagonal and are the same, they will cancel each other out, okay? That's something we can go into another time if you're really curious about why. But for today's discussion, we're going to say that that is true, which it is, and we know that it's true, and we can move on. So now that those units have canceled each other, all I'm left with is meters, which is what I wanted. And so that's why I set this problem up this way, where the information you're given goes in the first box, and that same set of units goes in the bottom of your conversion factor. That way they cancel, okay? Now, if we do the math on this, you will get 300 times this decimal, 0.3048, and you will get 91.44. That's the numerator, just multiplying the numbers. The bottom is just 1 times 1, which is 1, okay? The units, well, feet canceled because it's diagonal, and all I'm left with is meters. So I'm going to put an M here for meters, and any number divided by 1 is just itself. 91.44 meters. This is the same distance as 300 feet. All I did was change from one set of units to the other. So both of these numbers are different, but because they're different units, they actually measure the same distance. 300 feet for the length of a football field, which is equivalent to 91.44 meters. Let's look at another example where we use speed. In this problem, we're going 60 miles an hour, driving down the highway, and what we want to do is convert that to a metric speed of something in meters per second, okay? Meters per second versus miles per hour. We're given the first one, and we want to calculate the second one. And for this problem, what we're going to see is that 1 mile per hour, and I get this just from looking it up. Again, you can use online or you can use a textbook. 1 mile per hour is equal to 0.447 meters per second. These speeds are equivalent. Different units, but if you're walking at 1 mile per hour and the person next to you is walking at 0.447 meters per second, you're going the same speed, okay? This is the conversion or the decoding ring between these two units of measure. So let's go ahead and do the problem. We're going to fill out our boxes. We're multiplying. And remember that this first box is the information that we are given. So step 1 is write down what we know or what we are provided with, okay? This is what we have, 60 miles an hour. And we want to convert it to meters per second. So what I'm going to do, because I want the units to cancel, I'm immediately going to put miles per hour in the bottom so that they cancel, and I'm going to give it the number 1, okay? 1 mile per hour is going to be the denominator of my conversion chart or my conversion factor, and the numerator is going to be the units that I want, okay? What you want for units on top and what you want to cancel on the bottom, okay? And how many meters per second are equivalent to 1 mile an hour? That's where this conversion comes in, all right? So I'm going to type or write 0.447 meters per second. So these are equivalent speeds, but they're going to allow me to convert from one system to the other. Then we're going to remember that anything can be divided by 1, and now I have 2 fractions that are multiplied, so I can just go straight across the top and straight across the bottom. Before I do that, I'm going to remember that the miles per hour, because they're diagonal, are going to cancel. A quick note, if you have fractions that are added or subtracted, this canceling does not work. It only works if you multiply fractions. It also works with division, but that's a different discussion about what to do when you divide fractions. But when you're multiplying, these can cancel each other the same way that numbers could cancel each other. And so now that they've canceled, we're going to look at the bottom and say, I've just got 1 times 1 is 1. That's simple enough. The numerator is going to be 60 times this decimal of 0.447, and that's going to give us 26.82, multiplying those two numbers together. And the units that go on there are meters per second. Okay? And because we're dividing by 1, that doesn't change the number. So our final answer, 26.82 meters per second. For this last example, we are going to make up a problem where we have a 250-ounce dog, okay? Got a pet dog, 250 ounces, and what we want to know is how many kilograms does that dog weigh? This is going to be a two-step problem, and so what I wrote are two different conversions on here. 1 ounce has the weight of 28.35 grams, and 1 kilogram is 1,000 grams, okay? So the way we're going to do this problem was we're going to convert ounces to grams, and then from grams, we'll go to kilograms. Let's start by filling out our first box, okay? We're going to multiply what we were given by the conversion factor. So we were provided 250 ounces. If ounces is up here, then I want ounces in the denominator, and I want it to have the number 1. Okay? Well, what in ounces is equivalent to grams? 1 ounce is 28.35 grams. So what I was given at the beginning is going to cancel, and the new units that I will have are up here in the numerator. Okay, and then any number can be written divided by 1. Now I have two fractions that are multiplied, and I go straight across the top and bottom. Ounces is going to cancel. And on the denominator, I have 1 times 1 is 1. And in the numerator, I have 250 times 28.35. This is 7,087. And I'm just going to round it. There's a small decimal here, but the fraction or the decimal of an ounce is a very small number. So we're just going to leave it as a whole number. 7,087 what? Grams, because that's what's left over after the ounces cancel. Now, because the problem asked for kilograms, we're not done. We've converted from ounces to grams, but now we need to go from grams to kilograms. So we're going to do this whole process one more time, but it's already set up. Now, this becomes the new piece of information that we have, just like 250 was. And I'm going to multiply this problem by a conversion factor. I don't want grams anymore, so I'm going to put 1 gram in the denominator, okay? That way grams is going to cancel. Now, look what happened here. This conversion factor that I've got, while true, is not going to help us because I need 1 gram equivalent to something in kilogram. This conversion factor up here is a little bit backwards because it assumes 1 kilogram and 1,000 grams. Okay, so what I can do is I can divide both sides by 1,000. And what I'm going to get is 1 gram is equal to 1/1000th of a kilogram. That's just a different way of using this same conversion. And you might have to do that on your own, or if you're using an online lookup, you can just type that in and say how many kilograms is 1 gram. All right, so 1 gram is what I have in the denominator, and that is equivalent to 0.001. That's a decimal version of 1/1000th kilograms. Okay. So now, again, I'm going to multiply, and grams are diagonal, so they're going to cancel. And 1 times 1 is just 1. And in the numerator, I have 7,087, basically divided by 1,000, or times 1/1000th. And so that's going to give you 7.087, and the units that we have left over are kilograms. And there it is. So far, all of our examples have had denominators with 1 of whatever unit. So this example will show you something different here. We have 72 inches, and what we want to do is convert that into however many yards. Okay? This is all straight measurement. This isn't square yards. This is a straight distance. So 72 inches, how many yards is that? Okay, well, let's go ahead and set up the problem. I'm provided 72 inches. That's what I'm given. I'm going to multiply by a conversion factor, and I want inches to cancel. So inches goes in the denominator of my conversion factor so that it cancels. That means that yards goes up here, and now I need to fill in the numbers that go with this conversion, okay? 1 yard is equal to 36 inches. In all the previous examples, we had a 1 down here, and that makes it a little bit easier, but I want you to see that it doesn't matter if you have the 1 in the numerator or the denominator, okay? In this case, we have the 1 in the numerator. 1 yard is equal to 36 inches in the denominator. That's okay. We still want to make sure that inches cancels out because that's what I was given, and yards is what I'm left with because that's what the problem asked for. Anything can be written over 1. Now I have 2 fractions that are multiplied, and that means I can go straight across the top and the bottom. Inches is diagonal in a multiplied fraction. We can cancel those, okay, just like before. But now my denominator says 1 times 36. Well, that's 36. The numerator, 72 times 1, is 72, and the only units that are left are yards. 72 divided by 36 is 2. And so the final answer to this is 2 yards. And you can see that the same process still works even if the denominator doesn't have a 1. You just have to make sure that when you multiply, you look at what numbers you have so that the math comes out correct. So today we saw a simple and clear way to set up a unit conversion problem so that it's repeatable every time and it takes the confusion out. Hope you enjoyed the video. Go ahead and leave me any comments, hit subscribe, and we'll see you next time.